Good morning, everyone. So, welcome to my YouTube channel, Maths Subscribe. Today, we are going to see first practice set on the topic functions of bounded variation. Till now, if you have not subscribed my YouTube channel, subscribe it for such type of interesting practice sets. So, let's start today's session now. So, first question is let f be a function of bounded variation on closed interval AB such that the absolute value of fx is greater than equal to k for some k greater than 0. Then first is 1 upon f is not function of bounded variation. Second is 1 upon f is function of bounded variation. Third one is 1 upon f is unbounded. And fourth is none of the above. So you see that I have done one derivation on it. What was that? Solution. I have done this if g and f from closed interval a b to r be functions of bounded variation and fx is equal to greater than equal to k for some k greater than 0, then g upon f is also function of bounded variation. Okay. So in question it is given f is function of bounded variation. I will select some g. Let's say let's say g is let gx is equal to 1 for all x belongs to closed interval AB. So we know that this is constant function. So this implies g is function of bounded variation because it is a constant function, or you can say monotonically increasing because constant functions are monotonically increasing as monotonically decreasing. So this is a bounded function of bounded variation as it is constant, and constant functions are functions of bounded variation. So I will put the value gx is equal to 1. Then what does it imply? Implies this implies 1 upon f is function of bounded variation. Okay. Bounded variation. So which option is correct? First option is not correct because it is function of bounded variation. Second option is correct. 1 upon f is unbounded because once a function is of bounded variation, it is always a bounded function. So this is not correct. So D is also not correct. So option B is correct only. So let's see another question. So it is given f(x) is equal to sine 1 upon x for x belongs to 0 to 1 and at 0 it is 0. Option 1 is given f is function of bounded variation on closed interval 0, 1. Second is f is not function of bounded variation on closed interval 0, 1. C is f is unbounded on closed interval 0, 1. T is F is continuous on closed interval 0. Okay. So let's check it first. So you see that Fx is equal to sine 1 upon x if x belongs to open 0 and closed, and 0 if x is equal to 0. So I am taking this partition. Pn is equal to this is 0, 2 upon 2n minus 1 pi, then 2 upon 2n plus 1 upon pi. Okay, 2 upon pi, 2 upon 3 pi, and last one is 1 upon pi. Okay, so I am considering, I will show that F is not of bounded variation on closed interval 0 to 1 upon pi, which is subinterval of 0 to 1. If I can show that on a smaller interval it is not function of bounded variation, it cannot be or bigger one, because once a function is bounded variation on a larger interval, so it will be in some subinterval also. Okay, so I am going to prove that it is not function of bounded variation on 0 to 1 upon pi, because pi value is greater than 1. So 1 upon 0 to 1 upon pi lies in between 0 to 1 interval. Okay. So what is this? So SPN, what is this? This is F 1 upon pi minus F 2 upon 3 upon pi plus F 2 upon 3 upon pi minus F 2 upon 5 pi F 2 upon 2n plus 1. So it is 2n plus 1 here. Okay. Two n plus 1 pi here, 2n minus 1 pi here. Okay. 2n minus 1 pi. Okay. Let me write it again. Plus F 2 upon 2n minus 1 pi minus F 2 upon 2n plus 1 pi. Okay. And last one is F 2 upon 2n plus 1 pi minus f0. Okay. So what is this? Pi 1 upon f is equal f at 1 upon pi. What is the value of this? Is 0. This is pi minus. This is sine 3 pi by 2 value. 3 pi by 2 value is minus 1. Minus 1. This is 1. Okay, like that. It will be go. Or it will be minus 1 some here, minus 1. And finally it will be plus minus 1. Either it will be plus or minus. And in the this interval it will be of same sign. After minus is there. Alternatively plus minus will be there. Okay. We do not know it is plus or minus. Okay. Alternatively it will be. So it is 1 plus 2 plus 2 plus 1. So it is 1, 2. How many points are there? 0 to 0, 1, 1, 2. It is 1, 2, it is so what is this? This is how many times? 2 plus 2 plus 2. This is n times. So 2n. It tends to infinity as n tending to infinity. So this implies 1 upon x is not function of bounded variation. So this implies, because it is tending to, this implies bf 0 to 1 upon pi tends to infinity. Okay, so this implies f is not function of bounded variation on 0 to 1 upon pi. If it is not on 0 to pi, this is implied f is not on 0 to 1 because it is not on a smaller domain. So in a larger domain, it cannot be. So which option is correct? F is function of bounded variation on 0, 1. It is not correct. F is not function of bounded variation on 0, 1. It is correct. F is unbounded. No, F is sign functions are bounded. So it is bounded. So it is not correct. F is continuous. F is not continuous. Because in the neighborhood of 0, it oscillates. So it is not continuous. Okay. So B option is correct. So third question is fx is equal to sine x to the power n into sine 1 upon n. 1 upon x. X belongs to open 0, 1 close. And n is natural number. At x is equal to 0, function is 0. Then f is function of bounded variation is n is equal to 1, n is equal to 0, n greater than equal to 2, none of the above. If we take So fx is x to the power n sine 1 upon x if x belongs to 0 and 0 if x is equal to 0. So if we take n is equal to 0, then what is fx is equal to sine 1 upon x if x is. But this is not function of bounded variation. It is not function of bounded variation. We have already checked in second question. Okay. So first option, so second option is not correct. Okay. What about n is equal to 1? At n is equal to 1, what you have? You have this one. This is also not, it is not of function of bounded variation. Same partition you can take. You take same partition and check that this function is not bounded or variation. Or another way is to say that it is not function of bounded variation, because we have done one example where in place of 1 here, in place of 1 there was pi. So either it is pi or some constant, it will not affect anything. Such type of function are not function of bounded variation. Okay. So first option is also not correct. N is equal to 1. Or you can check by same partition as we have done in question number 2, second question. Now what about n greater than equal to 2? So you check at derivative at 0. Limit what is this? But n is greater than equal to 2. So this is 0. And what about derivative? If x is not 0, then what is? This is n x to the power n minus 1. Okay. Sine 1 upon x. And this is x to the power n into 1 upon x square cos 1 by x. So this is n x to the power n minus 1 sine 1 upon x plus x. This is minus. So this is to the power n minus 2 cos 1 upon x. So what is the derivative? Derivative is bounded by, because sine is bounded and x is taking it from 0 to 1. Sine is bounded by 1, cos is bounded by 1, and x is from 0 to 1. So it is bounded by, so it is bounded by 1. It will be n from this, it will come because both are bounded by 1. And this is also bounded by 1. So it is less than for all, for fixed n. Each fn is bounded. For fixed n, it is bounded. So once you have a function differentiable and its derivative is bounded, then such functions are functions of bounded variation. So this implies when you take f n greater than equal to greater than 0, then f is function of bounded variation. For n greater than equal to 2, it is, this implies f is of bounded variation. Okay. So which option is correct? because we have done such result. If your function is the derivative of function exists and it is bounded, then function is of bounded variation. So this function depends on n, some n, and its derivative is bounded by n plus 1 if n is greater than or equal to 2. So the f is function of bounded variation if n is greater than or equal to 2. Okay. So fourth question is, which one is true? Every continuous function is function of bounded variation? No. Because you see this example. Fx is equal to x sine pi upon x if x open 0, 1 close, and 0 if x is equal to 0. This function is continuous but not of bounded variation. This function is continuous but not of bounded variation. So first option is not correct. Second option is every function of bounded variation is continuous. No, this is also not correct because I can take this function fx is equal to 0 if x belongs to close 0, 1 open, and 1 if x is equal to 1. This function f is monotonically increasing. F is monotonically increasing. So this implies f is of, because every monotonically increasing or decreasing function is function of bounded variation. So it is bounded variation. Okay. So option number B is also not correct. Okay. Option B is also not correct. Because this function is not continuous at 0. So f is not continuous. This f is not continuous at 1. But it is of bounded variation at x is equal to 1. Okay. So second option is also not. Every function of bounded variation is unbounded. We have proved that if function is of bounded variation, it is always good. So option C is also not correct. So none of the above is true. So option number D is correct. None of the above. Okay. Now move to next question. Which of the following function is of bounded variation? We know that it means which of the following function is of bounded variation. We know that sin x functions are Lipschitz functions, and I told that sin x solution. So I told that Lipschitz function. If fx and fy is less than k times x minus y for some k greater than 0, this implies f is Lipschitz function. Every Lipschitz function is of bounded variation. Okay. Sin x minus sin y is less than x minus y. Similarly, cos x minus cos y is less than equal to x minus y. So this implies sin x, cos x are Lipschitz functions. So Lipschitz functions are functions of bounded variation. We have done some result. You can find a lecture on this, okay, in my playlist on functions of bounded variation. So this implies sin x and cos x are functions of bounded variation. Once you have functions of bounded variation, two functions of bounded variation, their sum and their difference will also be function of bounded variation. Okay. So we know that sin x is function of bounded variation. Cos x is also function of variation. So there some sin x plus cos x and sin x minus cos x will also be functions of bounded variation. So all the above, because sum and difference of two functions of bounded variation is also functions of bounded variation. Okay. Since sum and difference of two functions of bounded variation is of bounded variation. So this implies sin x plus minus cos x are also functions of bounded variation. So option number D is correct, because sin x is a function of bounded variation, cos x is a function of bounded variation, and sum of these two functions sin x and cos x, that is sin x plus minus cos x functions, are also function of bounded variation. So option number D is correct, all of the above. Question number 6. Every function of bounded variation is difference of two monotonically increasing functions. Okay. Difference of two monotonically decreasing functions, sum of monotonically increasing functions and monotonically decreasing functions. So let's see. Solution. We know that by Jordan theorem, f can be written as p minus q, where p is equal to 1 upon f bf plus f, q is equal to 1 by 2 bf minus. P and q are monotonically increasing. Okay. So first option is correct. Monotonically increasing. We can write a difference f as a function of bounded variation can be written as a difference of two monotonically increasing functions. So first option is correct. And now we want to write as a difference of second option. It is given monotonically decreasing. So f is, I can write same f like minus q minus p minus p. So now, because now these two functions minus q and minus p, because p and q are monotonically increasing, you take minus, they will be monotonically decreasing. So f can also be written as a difference of two monotonically decreasing functions. Okay. So option number B is also correct. Okay. Now third one is sum of sum. It is saying sum. So F can also be written as F is equal to P minus Q. I can write P plus minus Q. So P is monotonically increasing. And minus Q is monotonically decreasing. Okay. So option number C is also correct because we can write F as a sum of monotonically increasing and monotonically decreasing. So all first three options are correct. Okay. So which option is correct? All of the above. So option number D is correct. Okay. And let's move to next question. Let F and G be function of bounded relation, then which of the following is not true? Okay. We know that we have to find a option which is not true. We know if you have two functions of bounded variation, their sum is also function of bounded variation. So option number A is correct. Okay. So if you have a function of bounded variation, you take a scalar multiple of that. That is also function of bounded variation. You take alpha is equal to -1, then alpha into f, that is alpha is -1, so minus f function is also function of bounded variation. So option number B is correct. So product of a function of bounded variation is also function of bounded variation. That is also correct. Now D option is correct because D option is correct. Why? You take this function fx is equal to 1 on 0 1. That is function of bounded variation because it is a constant function. Now you take interval 0 to 1. 0 to 1. Okay. Okay. Sorry, 1 minute. I'm taking another question. So I should take here. I am to take f upon g function. So let's take fx is equal to take this function. You take take f is equal to 1 on -1 to 0 and take gx is equal to x if you are taking x from -1 to 0 open. Okay. And 1 if x is equal to 0. Then what is this function? So what is f upon g? This is 1 upon x if x belongs to -1 to 0, and this is 1 if x is equal to 0. You can check that gx is never 0, but f upon g is not bounded. This is not bounded. It's not bounded. And so if not bounded, then this implies f upon g is not of bounded variation, because every function of bounded variation is bounded. It's not of bounded variation. So you see that f is of bounded variation, and gx is monotonically increasing function. This is monotonically increasing function. So f is of bounded variation here, g is of bounded variation. Okay, but f upon g is not of bounded variation. Okay, so option number D is correct. Okay, because g is monotonically increasing. Okay, so f is of bounded variation, g is of bounded variation, but after f upon g is not bounded. So f upon g is not function of bounded variation, because in the neighborhood of 0, 1 upon x will become infinity, minus infinity. Okay, so that is why it is not bounded. Okay, that is not why it is not a function of bounded variation. So let's see next question. What is the variation of sin x or 0? We know that sin x function is function of bounded variation. Now we have to direct tell what is the variation of it. Solution. Fx is equal to sin x on 0 to pi by 2. F is monotonically increasing, because sine functions are monotonically increasing on 0 to pi by 2. So what is the variation? So Bf sine 0 to pi by 2, what is that? Monotonically increasing functions variation is given by Fb minus Fa. So Fb is pi by 2, B is pi by 2, Fa is 0. So sine pi by 2 minus sine 0. So what is 1 minus 0? That is 1. So variation is 1. So which option is correct? Okay, 1. C option is correct. A continuous function is of bounded variation if and only that it can be written as a difference of two monotonically increasing functions, difference of two continuously monotonically decreasing functions, sum of monotonically increasing and sum of monotonically decreasing. So it is easy. Why? Okay. Solution. So we know f is continuous. A function of bounded variation is continuous if and only p and q are continuous. Okay. And we know that f is nothing but difference of p minus q. Same thing you can write minus q minus p minus q. Same thing you can write p plus minus q. So if f is continuous, p and q are continuous. So p and q are continuous. So first option is correct, because f can be written as a difference of two continuous monotonically increasing functions, because p and q are monotonically increasing functions. Now second option is also correct, because minus q is monotonically decreasing, it is continuous. Minus p is also monotonically decreasing and it is continuous. So f can be written as a difference of two monotonically decreasing continuous functions. Okay. Now second option is correct. Okay. Third option is also correct, because p is continuous, monotonically increasing, and minus q is monotonically decreasing, it is continuous also, and f is sum of these p plus minus q. So third option is also correct. So all the options are correct. So option number D is correct. Okay. Let f close interval 0 to r be a continuous function. This is the last question. Okay. F is function of bounded variation on close interval 0, close interval a to b. Then Pf is monotonically increasing function on 0, 1. Yes, we know that if function is bounded variation, the variation function Bf is also monotonically increasing. The first option is correct. Second option is Bf is function of bounded variation on AB. We also know that monotonically increasing functions are functions of bounded variation. So option number B is also correct. Now option number C is Bf is not of bounded variation on closed interval 0 on AB. No, it is not correct because it is monotonically increasing. Monotonically increasing function are of function of bounded variation. So C option is not correct. So A and B options are correct. So option number D is correct. Okay. So option number D is correct. Okay. So today's practice set up to this. If you have any problem related to this set, you can comment me on my YouTube channel. I will take care and I will discuss in next practice set. Like, share, subscribe and comment on my YouTube channel. Thank you very much for today's session. Thank you very much. We will see you in next session. Okay. We will discuss problem practice set in next session. Okay. Thank you very much for today's session. Thank you very much. We will see you in next session.